Hello, how's it going? Let's jump in and take a look at where we're at. I've made a few changes here. They're not dramatic, they're mostly in the camera system. So as you can see, as I walk around, that camera is dollying in and out. And I've also set up a camera shake. Now at the moment this is just rigged to my S key, just so I can show it a few times. If I hit S, there's it's more obvious on the actual screen when you're playing, but this camera shake will be implemented when an arena begins. So when I walk into a trigger area and the blocks pop up and the waves of enemies show up, then I also get a little subtle shake there. And this has actually been really effective when I've been playtesting this and I've forgotten that it was going to happen. It's just one of those things. It's sort of cool, I think. Now, I'm a little more iffy on this camera dollying. I think it might need tweaking. It's currently based on the player's velocity, the player's speed. So when I start walking, it pulls in, and not too much thought went into it, but the basic idea is to make the action more exciting, so you can just blaze through levels, but you'll lose some of that big perspective. So it's really effective, I think, when jumping. So if I jump right now, the camera pulls in, and then as I reach the peak of my jump, it pulls out. And if I do this one here, have a look at this. The camera really pulls in and then pulls out. I really like that. I really like that effect when jumping. What I'm a little so-so on is it seems like it comes very suddenly right now when I start walking. So it immediately pulls in. Can be a little jarring. I don't know, but this might be one of those things, as you play the game more, it just becomes like the style of the game. I don't know. Another change that I made, and this is much more subtle, although it was equally nightmarish to debug, is I have implemented uniform buffer objects to hold the skeletons. So previously I was doing it completely naively. That was, we would have a uniform which was an array of mat 4s, and I got around, instead of having, because I've got 16 skeletons, instead of having 16 individual uniform locations, which I did have at one point, I got around that by capturing the location of the first uniform, like transform 0, bone transform 0, and then to that location uploading 16 mat 4s in one go. And it was all contiguous in memory, and that uploaded everything in one go. But that's a bit of a hack, and the best practice in that case is to use something like a shader storage buffer object or a uniform buffer object. However, I want to keep this to OpenGL 3.3 to maximize compatibility with Apple. I don't know why, they just introduced some crazy runtime fee. But for that reason, I went with uniform buffer objects. And I was debugging it and I got all sorts of nightmarish things. I'll pop up a video that I took of one character controlling the armature of another character. And what it came down to in the end, let me close that. Okay, this is the thing that tweaked me off, is when I opened it up in RenderDoc, most of the time I was getting the same issues, until one time I opened it in RenderDoc and the thing was working perfectly fine. And I thought back to another issue I had in the past where, hey, anytime RenderDoc is working but my local deployment isn't, it indicates that it is sort of a pointer versus value issue. And so I switched over to pointers and then it worked fine. So I've done the devil's deal there, in terms of pointer dereferencing. It's not great, but it does work. Okay, now, Andrew from the future here. I recorded that previous section, and then in the time between recording it and editing and uploading, I went ahead and added multi-threading to my system. So I just want to talk through how I did that. Now, I have a habit of really messing up multi-threading. No matter which multi-threading thing I'm trying, I always find a way to mess it up. But unfortunately, I haven't been able to mess this up too badly. This is task flow. Task flow is designed for basically task level parallelization. So say for instance, in its most basic form, you have like a bunch of tasks, and generally they'll proceed from start to finish, but some of them can execute at the same time. So what I've been doing, and I haven't finished this yet, but I've been going through my system and I've been reasoning about which systems rely on the results of other systems and trying to chain that together. So we start at the beginning of our frame where we update the player, by handling key presses and controlling them and things like that. And then that generally flows through all of the tasks, update the physics components, the health components, and so on, right up to the end where everything's been updated and we can render. But what I can do is analyze this a little more closely and say, well, hang on a second, the particle system can just start from the beginning of the frame and run in parallel on a different thread. The updating of the camera relies on the info that was set, like the player's velocity is what I'm saying. And the AI depends on the player's position, basically. So I could even shift that. Well, it's a chicken and egg situation, isn't it? Anyway, so this is sort of what I've been doing. And like I said, it's a work in progress. There are some considerations. With multi-threading, OpenGL hates multi-threading. So if I go to the run section, this is my run loop here. I'm not sure how visible this is. Just make it get a little closer. But first up, any GLFW stuff needs to be done on the main thread. So polling events, in other words, clearing all the key press events, has to be done separately on the main thread. Similarly, all the OpenGL stuff has to be done on the main thread, and that includes the uploading of various uniform buffer objects and all of that. Okay, but otherwise, most of the update is handled by this executor, which executes a task graph. Now, the task graph is basically what I've been planning out here, all of these tasks and their dependencies. The task graph is constructed down here. Each task is constructed based on a lambda, so we pass in a lambda, which is like, do all this stuff, this is the task, okay? So if I place all of these tasks without any constraints, then they will be fully parallel and they'll like all execute at the same time, and it'll be horrible. So what I also do is, after placing all the tasks, I define the constraints on the tasks. So like, we have to update the player before we update the camera, we have to update the player before we update the AI, and so on and so on. You can check out the task flow documentation for more detail there. But this is how it runs in practice. In other words, it more or less goes exactly the same as before. Now, there's two reasons for that. Probably the primary reason is that this program is GPU blocked, not CPU blocked. Secondary reason is that this laptop only has one thread. With hyperthreading, we can pad that out to 2, but if we look down the side here, we can see that we are in fact chewing through a considerable amount of our CPU, more than we were before. So that's a good sign. It just warms my heart to know that in the future, when they make computers with 128 threads, this little indie game will be consuming some portion of that. But, I mean, I'm very happy to say that the thing basically works, and in multi-threading, that is a win. Okay, so that'll be it for me. Hope you enjoyed that, and yeah, see you around. Bye.